Hello, math buddies! Good day! I'm Teacher Ann, your math buddy, and welcome to another fun, challenging, and amazing mathematics discussion with me. Always remember that the best way to learn mathematics is to do mathematics. For today's lesson, we will be discussing classification and ways of naming a set. But before going any further, let me first share to you lesson objectives. First, illustrate finite and infinite set. Second, differentiate equal and equivalent sets. And last, enumerate ways of naming a set. Let's have here some unlocking words difficulty, so we might encounter these words as we go along with our lessons. Integers. So, these are numbers that consist of negative infinity or the negative numbers, the zero, and the positive infinity or positive numbers. Whole numbers. Whole numbers are a set of numbers that starts with 0 and a set of counting numbers. So we have 0, 1, 2, 3, 4, 5, and so on. Next, we have the natural or the counting numbers. From the word counting itself, so when we count, we start with 1. So we have here 1, 2, 3, 4, 5, and so on. Even numbers. We have here the set of 2, 4, 6, 8, 10. So it's just like skip counting by 2. And odd numbers, we have 1, 3, 5, 7, 9. So these are examples of odd numbers. Prime numbers are numbers whose factor is 1 and itself. So we have here 2, 3, 5, 7, and so on. Remember, prime factors has no other factors except 1 and itself. Composite numbers. So these are numbers whose factors, aside from 1 and itself, we still have other factors. Just like 4. Aside from 1 times 4, we do also have 2 times 2. 4, 9. We have 3 times 3 and 1 times 9. For 12, we have 1 times 12, 6 times 2, 3 times 4. So, these are examples of composite numbers. What about perfect squares? Okay, so these are numbers which is the product of multiplying a number by itself. So just like 1. So 1 times 1 is 1. 9. We have 3 times 3, 9. 25. 5 times 5, 25. So these are called perfect squares. Multiples, or we have here skip counting by. So for example, we have multiples of 2. So we skip count by 2. 2, 4, 6, 8. Okay. And let's say 4. So skip counting or the multiples of 4. We have 4, 8, 12, 16, 20. So those are what we call multiples. Factors. So these are numbers which can be divided without a remainder. So, say for example, we have 12. 12 divided by 4 is 3. Okay, so 4 and 3 are factors of 12. Now, let's define what are finite and infinite set. A set is said to be finite if it contains a definite number of different elements, while infinite set, counting the elements in the set, cannot come to an end. An ellipsis, so this is the ellipsis indicated after the last identified element means that there are other elements of the set. So, in this example, when we say finite, definitely can be counted. So, the set whose elements can be counted is called finite, while otherwise, it is infinite, elements that cannot be counted. And usually, we use ellipsis to indicate that there are other elements of the set. So let's have here some examples. Counting numbers. So can you give me an element that belongs to this set? Right. So we have 1, 2, 3, 4, 5, and so on. So what can you say about this set? Right. Set A is an infinite set. It's because, as you notice, there is the symbol or the ellipsis here that indicates there are other elements in the set. So, continuous yung element. So, hindi lang until 5. Pwede nga abot pa yan siya ng millions. So, this is set A is an infinite set. Another one. Set B contains counting number less than 5. Can you give the counting numbers less than 5? Right. Set B, we have 1, 2, 3, and 4. So we do not include 5 because it says here less than 5. So what can you say about this set? Is this finite or infinite? Right. This is finite set. It's because the elements can be counted. So, that's it. Another example. Set C contains letters in the English alphabet. So, what are the elements of this set? We have A, B, C, D. We have here ellipsis, then X, Y, Z. Is this finite or infinite? Right. This is a finite set because we know that this set contains only letters from A up to Z. Though gumamit tayo dito ng ellipsis, it doesn't mean na infinite siya. Okay? Kasi alam naman natin na yung English alphabet is from A at saka up to Z at mabibilang siya natin. Gumamit lang tayo ng ellipsis dito para hindi naman masyadong mahaba na isusulat natin lahat ng letters from A to Z. Okay. Last example, we have set D, whole numbers greater than 20. Finite or infinite? So what are the elements under this set? So we have 21, 22, 23, 24, 25, 26, and so on. And of course, this is infinite set. Naintindihan nyo na ba? Ano ang kaibahan ng finite at saka ni infinite? Now, let's differentiate equal and equivalent set. Two sets are equal if and only if they contain exactly the same elements, while two sets are equivalent if and only if there is a one-to-one correspondence between the sets. So, matatawag nating equal ang dalawang set if yung element ng isang set is kapareho mismo ng elements ng kabilang set. At equivalent naman kung ang bilang ng isang set is kapareho ng bilang ng kabilang set. So let's have here an example. Set X contains apple, banana, and mango. Set Y contains orange, apple, and banana. And set Z contains banana, mango, and apple. So, saan dito yung set na masasabi nating equal? Right! Set X and Z are equal sets dahil pareho silang may apple, may banana, at saka may mango. Saan naman natin mabibilang ang set X at saka set Y? Okay, we have set X and Y and set Y and Z are equivalent set. Bakit equivalent? Kasi ilang elements ba meron si X? 1, 2, 3. Ilang elements naman meron si Y? 1, 2, 3. Parehong may tatlong elements si X at saka si Y at saka si Y at Z. Though hindi lahat pareho sila mismo ng elements dun sa set. So, tandaan, si equivalent set ay pareho ang bilang ng bawat set. They contains the same number of elements. Let's have here more examples. We have set A contains 1, 2, 3, 4, 5. Set B, 3, 5, 6, 9. Set C, 4, 5, 2, 3, 1. And set D, 2, 4, 6, 8, 10. What can you say about set A and set C? Are they equal or equivalent? Right, they are equal sets because set A and set C both contains the same elements. We have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So set A and set C are equal sets. What about this? Set A and set D. They are correct. They are equivalent sets because they do not have exactly the same elements, but rather they have the same number of elements. So for set A, we have 1, 2, 3, 4, 5 elements. And for set D, we have 1, 2, 3, 4, 5, another 5 elements. So both contains 5 elements. That's why they are equivalent sets. Now let's have set B and set C. Are they equal? Are they equivalent? Okay, right. Neither. They are neither equal nor equivalent. And last, we have set C and set D. Very good. They are equivalent sets because they contains the same number of elements. If two sets are equivalent, Are they equal? Pag yung dalawang set ba daw ay equivalent, makukonsider din ba natin siyang equal? Tama. The answer is no. Why? Dahil, wag sabihin nating equivalent, dapat pareho ang bilang. Pag sinabi nating equal, dapat mismong element talaga ang magkakapareho. So, if two sets are equivalent, then they are not necessarily equal. If two sets are equal, are they equivalent? Lahat ba ng equal sets are equivalent? Right. The answer is yes. Dahil, alam naman natin na if they are equal, pareho mismo sila ng mga elements. So, definitely, kung pareho sila ng mga elements, pareho din ang bilang ng mismong elements nila. Naintindihan? Okay. Now, let's go to ways of defining a set. The first one is what we call the rooster method. Ano ba ang narinig dito? This is a method of describing a set by listing each element of the set inside the symbol, the set bracket. Okay, so ito yung symbol, yung bracket mismo. Okay? In listing the elements of the set, each distinct element is listed once, and the order of the elements does not matter. So, pag sinusulat daw natin yung mga elements mismo, sinusulat natin siya ng isang beses lang at hindi na natin to inuulit. Example. Number 1. Colors of the rainbow. Can you list all the colors of the rainbow? Okay, right. We have here the red, orange, yellow, green, blue, indigo, and violet. So, in rooster method, isusulat lang natin mismo isa-isa lahat ng elements na hinihingi dun mismo sa set. Second one. Even set E is the set of even numbers less than 10. Can you give the elements under this set less than 10? Even numbers. So we have 2, 4, 6, 8. Very good. The third one, we have vowel letters in the English alphabet. So let's list all the vowel letters in the English alphabet. And we have A, E, I, O, U. So this is how we do the listing method or the rooster method, by simply listing each element of the given set. Next is, we have the set builder notation. Ano ba sa set builder notation? It is a method that lists the rules that determine whether an object is an element of the set rather than the actual elements. So instead of writing all the elements, we simply what? Write the rules. So rules yung sinusulat natin instead of the actual elements. So let's examples. Set C equals the colors of the rainbow. So how do we write it in set builder form? So this is how we do it. So we have here C equals open bracket or braces, then X slash x, then the rule is a color of the rainbow, then enclosed in another braces. So how do we read this one? So we read this as C is the set of all x such that x is a color of the rainbow. Next example, V. We have here A, E, I, O, U. So you notice that the given is written in listing form. So how do we write this one in set builder notation? So we have V equals, open braces, x such that x is a vowel letter in the English alphabet. Then enclose it in set braces. So how do we read this one? We read this as V is the set of all x such that x is a vowel letter in the English alphabet. Let's have here more examples. We have here a table that contains two columns, the rooster method and the set builder notation. Set A contains the elements 1, 3, 5, 7, 9. So how will you describe or write this set in set builder notation? Right! We have here A is the set of all x such that x is an odd number less than 10. What about this? B is the set of all x such that x is prime number less than 13. So the given here is in set builder notation and we need to write its rooster method. So what are the numbers or prime numbers less than 13? Correct! We have B contains the elements 2, 3, 5, 7, and 11. And lastly, we have 4, 8, 12, 16, 20, 24. So how will you describe this set in set builder notation? Right! They are, or set C is the set of all x such that x is a multiple of 4 less than 28. 4, 8, 12, 16, 20, 24 are all multiples of 4 less than 28. And that's it. I hope marami kayong natutunan sa lesson natin ngayon. Thank you for listening. See you again in our next discussion. Goodbye!